In this module, I am going to share with you an innovative way of teaching Huygens principle and its applications. Let us start the slide, the topic. Huygens principles. Why is this important? This is important as it helps us in predicting and understanding the classical wave propagation of light. What is its aim? Huygens principles are used to construct the secondary wavefront if primary wavefront is given. And according to this principle, first, each point of a wavefront is the source of secondary wavelets. Small waves are called secondary wavelets, which spread in all directions with the speed of the wave. The new wavefront is formed by drawing a line tangent to all the wavelets. What is wavefront? First of all, we should see what is this. What is wavefront? When a stone is dropped on the surface of water, disturbance moves in all the directions with equal speed in the form of ripples called wavefront. This is wavefront of water. Similarly, light energy starting from the source moves in all the directions with equal speed in a medium. All the particles lying at equal distance from the source vibrate at the same time or vibrate in the same phase. Thus, the imaginary surface of constant phase is called wavefront. This is simple definition according to NCERT book. Imaginary surface of constant phase is called wavefront. Here, I have taken the constructions of plane wavefront and spherical wavefront. Look at this. A dash, here A dash are primary wavefronts. And on the basis of Huygens principles, we will see that what is the position of the second wave, that is secondary wavefront. According to the first principles, we have to consider some points on the primary wavefront which act as fresh sources for the secondary. So I have taken some points. Let us see here. 1, 2, 3, 4 points. Here also 1, 2, 3, 4 points I have taken. Light moves with a speed equal to the speed of light. So here, if c be the speed of light, then ct will be the distance covered by the wavefront in time t. So in time t, the wavefront will cover ct distance. Now taking ct as distance, ct as radius, arcs are drawn from the points. I have taken first arc, second arc, third arc, fourth arc in both the cases, taking ct as radius. Tangents are drawn on the arcs, and when tangents are enclosed, then enclosing surface gives the position of secondary wavefront. So in both the figure, B dash are secondary wavefronts. In the first case, secondary plane wavefront, and in the second case, spherical wavefront, secondary spherical wavefront. Inward envelope is not taken because of the following reasons. I have taken only outward envelope or forward envelope, not in backward envelope. What is the reason behind it? According to two scientists, Huygens and Kirchhoff's, amplitude of wavelets in any direction making an angle theta with the normal to the wavelets is proportional to half into 1 plus cos theta. So for a point on inward envelope, theta is 180 degree and cos 180 degree is minus 1. So 1 minus 1 equals to 0. Therefore, the amplitude of the inward envelope becomes 0. This inward envelope is formed, but due to 0 amplitude, this is not shown in the diagram. How is this related with the construction of a simple rectangle? What I have written in the topic, innovation way of teaching. I have related Huygens construction with the construction of a simple rectangle. And for that, I have taken a question, construct a rectangle whose length and breadth are 5 centimeter and 3 centimeter respectively. So what do we do for constructing a rectangle? We draw any line. As in the wavefront, we take primary wavefront. We consider any point on the line for further construction. In Huygens construction also, we take certain points for further construction. In other words, we can say that each point on it is a fresh source for further construction. So this point A we can take anywhere on this line. Now we take another point B such that AB equals to 5 centimeter. In the wavefront, we have taken 4 points. Here we have taken only 2 points. Now, 2 lines perpendicular to the line AB are drawn at the points A and B. I have taken this perpendicular and this perpendicular. And in case of wave, we have taken propagation of light waves in a straight line from all the points. Taking breadth 3 centimeter as radius, arcs are drawn from A and B. Arcs we have taken. Similarly, in Huygens construction, taking CT as radius, we have drawn arcs from different points. Tangents are drawn on the arcs. Here tangents we have drawn, and I have enclosed both the tangents, which gives opposite sides of the rectangle. Similarly, tangents are enclosed in Huygens construction also, which gives the position of secondary wavefront. So, comparison. In Huygens construction, rectangle. In Huygens construction, we have taken primary wavefront. In rectangle, I have taken line. In Huygens construction, 2 points A and A dash acting as fresh sources. Here also we have taken A and B, whose distance is 5 centimeter. Rays passing through the points are perpendicular to the wavefront, yet perpendiculars are drawn at points. Arcs of radius CT are drawn from the points, and arcs of radius 3 centimeter, which is breadth, are drawn from the points. Tangents drawn on the arcs are enclosed to obtain secondary wavefront, and here tangents drawn on the arcs are enclosed to obtain opposite side CD of the rectangle. That's all. Thank you.